What if your flower pot could monitor the soil and surrounding environment, warn you when the water is running low, and even water your plant automatically? In this video, we are going to use Insight1 Smart Flowerpot Kit to build this project. The system can monitor temperature, humidity, light level, soil moisture, and water level when the soil becomes too dry. It can automatically activate a small water pump to water the plant. When connected to the XiaoZhi AI module, we can also check the flower pot's condition and control its watering system wirelessly. Before we start building, let's take a look at the main hardware components included in the kit. The kit includes an ESP32S3 development board, a XiaoZhi AI module, a soil moisture sensor, a temperature and humidity sensor, a light sensor, an OLED display, DuPont jumper wires, a small water pump, breadboard, and more. Before connecting anything, here are a few important safety reminders. This project is designed for low voltage power only, never connected directly to a 220 volt mains power supply. Doing so may cause serious hardware damage, fire, electric shock, or other hazards. Keep the ESP32S3 breadboard, USB connections, and exposed wires dry and away from the water container. During the initial test, leave the pump disconnected. First, confirm that the system and relay activate and deactivate correctly. We will connect the pump only after the control system has been tested. Children and students should complete this project with adult or teacher supervision. After knowing what not to do when handling the hardware modules, we can start wiring them. If you are new to electronics, don't worry. Insight1 provides step-by-step guides to help beginners connect the components correctly. And we're done! If you're building the project along with me, your setup should look similar to this. Before turning it on, compare every connection to the wiring guide. Make sure the power, ground, and signal wires are connected to the right place. Now that the hardware part is assembled, let's move on to the software side of the project. The Smart Flower Pot project is programmed using Visual Studio Code with PlatformIO IDE extension. First, download and install Visual Studio Code on your computer. After opening Visual Studio Code, select the extensions icon on the left side of the screen. Search for PlatformIO IDE and then install the extension. Once the installation is complete, you should see PlatformIO icon on the left sidebar. Next, select File, then Open Folder, and open the complete Smart Flowerpot project folder. Make sure you open the main folder containing the platform.ini file. You should also see folders named Include and SRC. There you have it! We have now installed all the necessary software tools we need for the project. Next, let's connect the ESP32S3 to the laptop, then we can build and upload the program to it. Don't worry about writing the entire program from scratch. The complete project code is already provided for your convenience. Open the PlatformIO in Visual Studio Code and select Build. This checks the code and compiles it for the ESP32S3 board. If everything is correct, the terminal should display the word Success. Next, select Upload to transfer the program to the ESP32S3. If the upload gets stuck at connecting, hold down the boot button on the ESP32S3 board. Start the upload again and release the boot button once the upload begins. After uploading the program, open the serial monitor and set the baud rate to 115200. During a successful startup, The serial monitor should show that the sensors, ESP now communication, and main system have been initialized. Now for the exciting part, it's time to test the system. For the first test, leave the pump disconnected. Connect only the sensors and the OLED display. After turning on the ESP32S3, the OLED should display the Smart Flowerpot title. It should then show the temperature, humidity, light level, soil moisture, water level, pump status, and current system state. Next, test the soil moisture sensor. Insert the probe into the soil and observe the reading on the OLED. The soil moisture value should increase from 0 to the accurate moisture level. Now, let's test the water level sensor. Attach the sensor to the outside of the water container. When the water is above the sensor's position, the display should show that the water level is normal. Based on our checklist, everything is working correctly. But before putting the pump into the water container, let's test the whole system first. First, make sure that the water level is shown as normal. Then allow the soil moisture sensor to detect dry soil. When automatic watering begins, you should hear the click sound. After the programmed watering duration, you should hear it click again as it turns off. Once the relay is working correctly, disconnect the power before we put the pump into the water container. Place the pump inside the water container. Then position the end of the tubing above the soil. Remember to keep the outlet away from the electronics. Let's turn the system back on and allow it to water the soil. When testing the system, use another container so that the plant would not drown. The relay should activate, the pump should begin watering, and the RGB LED should display a blue breathing effect. The pump will stop when the watering duration is complete, when the soil reaches a target soil moisture level, or when the water level becomes too low. For your reference, these are the meaning of each RGB LED light, colors, and effects. A flashing red light means the soil is too dry. When it shows breathing blue light, it means watering is in progress. When the LED is green, the system is operating normally. Isn't that great? We were able to successfully make the different parts of the system work together to water the plant. This is not possible without the help of these little data gatherers. They inform the ESP32S3 about the surrounding environment, soil condition, and water level. ESP then uses that information to decide whether the plant needs to be watered or is it safe to activate the pump. Now that everything is working properly, we can finally say that we have completed the project. What I mean is that we finished the first part of the project. Of course, we cannot forget the role of XiaoZhi in making everything extra special, providing us with wireless monitoring and control over the system. To connect XiaoZhi to the system, power on both devices and put XiaoZhi in its pairing or device scanning mode. XiaoZhi should discover the flower pot as a device named Smart Flowerpot.
I'm connected to a smart flowerpot device called Smart Flowerpot. It's paired via ESP now, and I can control its watering, check soil moisture, temperature, humidity, and light levels.
Once paired, XiaoZhi can request for the latest sensor data, check whether the pump is on or off, manually start watering, set automatic watering rules, and calibrate the soil moisture sensor. XiaoZhi, can you provide the flower pot data?
Sure, let me get a fresh reading from the flower pot. Here's the latest. Temperature is 26.6 degrees Celsius. Humidity 67.2%. Light is 467 lux. And soil moisture is still at 100%.
XiaoZhi, can you water the plant for 3 seconds?
I'll water the plant for 3 seconds for you.
Change the watering rule to water for 5 seconds when the soil moisture drops below 50 with a 30-minute cooldown.
Got it. I'll update the watering rule to 5 seconds when soil moisture drops below 50% with a 30-minute cooldown.
We have finally completed the Insight1 Flowerpot project. Or did we? No, it's for real this time. We were able to implement the Flowerpot's 4 main features. First, it can now monitor the environment and check for temperature, humidity, soil moisture, and light and water level. Second, we made it support automatic watering. When the soil becomes too dry, the system activates the pump and waters the plant. Third, we built in important safety rules for it to abide by. For example, if the ESP32S3 detects that the water level is too low, it prevents the pump from starting and flashes a purple warning light. And lastly, connecting the XiaoZhi AI allows us to monitor and control the system wirelessly. This project demonstrates how coding, electronics, automation, and AI can be used to monitor the real world and respond automatically to changing conditions. Once your smart flower pot is working reliably, try adjusting the watering duration and interval, moisture threshold, and warning levels to better match the needs of your plants. Once again, this is Insight1 Smart Flowerpot Kit. Whether you are learning independently or helping a young learner explore technology, this kit provides a practical way to develop valuable coding, electronics, automation, and IoT skills for today's technology-driven world. Thank you for watching. Remember to subscribe to our channel and don't forget to share your smart flower pot project with us. Again, see you in the next project.